All right, 4.5 is the section on perfect square trinomials and difference of two squares. The difference of two squares is really easy. Take a deep breath, because after we do factoring trinomials and we're doing bottoms up over and over and over again, you just want something easy. So the difference of two squares is really simple. The only thing you really need to remember is perfect squares. So if you have if you haven't seen perfect squares in a long time, the square root of 49 is 7. The square root of 25 is 5. The square root of 144 is 12. The square root of 121 is 11. The square root of 36 is 6. The square root of 4 is 2. These are perfect squares. So what we're going to do today is you're going to hear me say, what's the square root of this number? What's the square root of that number? So if you don't know your perfect squares, brush up on them real quick, and then it'll really help you when we do the problems in this section. So let's look at our first example, or our formula for this. You must be able to take the square root of both terms in the polynomial, and you must have a negative sign on one of the terms, a minus sign, for this factoring problem to work. So if you can take the perfect square, if you can take the square root of the first term and the square root of the last term, your formula means it's going to be the square root of a squared, the square root of b squared, one with the minus and one with the plus. That's factored form for this difference of two squares. So let's look at our first example. The square root of x squared is x. The square root of 16 is 4. And in factored form, I'm going to write the same thing twice, one with the minus and one with the plus. So this is it. All you're doing is you're taking the square root of both terms, and then you're going to write them twice, one with the minus and one with the plus. Now remember that I said you must be able to take the square root of both terms, and you must have a negative on one of the terms. So if you don't have a minus sign in between these two terms or in front of the x squared, you will not be able to do the difference of two squares. So keep in mind that you're looking to see if you can take the square root of both, and you're looking for that minus sign. So on the next one, the square root of x squared is x. The square root of 9 is 3. I'm going to write one with the minus and one with the plus. And it's that simple. So let's go ahead and do number 3. The square root of 49 is 7. The square root of x squared is x. The square root of 25 is 5. I'm going to write one with the minus and one with the plus. Alright. The next one, the square root of y squared is y. The square root of 64 is 8. One with the minus and one with the plus. Now the next one is tricky, very, very tricky. And the reason why it's so tricky is because I can take the square root of 36, no problem. I can also take the square root of 100. But they are both even. That's telling me they have a GCF. And even though we're not discussing GCF in this section, you still need to look for your GCF first in any factoring method. So 36 is even, 100 is even. I know 2 will go into both of them. Is there a bigger number that will go into both? Well, the only thing I know about 100, it relates to quarters. So that means that I can divide 2 into it. I can divide 4 into it. And so will 4 go into 36? Yes. So my GCF is going to be 4. And if I take out a 4 from 36, 4 will go into 36 9 times. 4 will go into 100 25 times. So I divided 4 into 36 and got 9, brought my x squared down. I divided 4 into 100 25 times, and I brought my y squared down. Now, since I have a binomial left, and a binomial means two terms, and you can only do the difference of two squares with a binomial, okay? So since I have a binomial left, and I can take the square root of 9, I can take the square root of x squared, I can take the square root of 25, and I can take the square root of y squared, I can do the difference of two squares now. So I'm going to bring my GCF down, and the square root of 9 is 3, the square root of x squared is x, the square root of 25 is 5, and the square root of y squared is y. One with the minus and one with the plus. That is in factored form completely. Okay, so not only did we have to do the GCF in that one, but we also had to do our difference of two squares. Now let's go ahead with numbers 6 and 7. I can take the square root of 9, I can take the square root of x squared, I can take the square root of 16. But since I do not have a minus sign in between, I have a plus sign, this is going to be a prime polynomial. Okay, it's very important that you be able to take the square root of each term and have a minus sign in between. So since there was no minus sign, I can't go any further with that polynomial. There's no GCF that I can take out. There's nothing I can do at 6 but write prime. All right. Now on number 7, I want y'all to notice one thing right off the bat, that I have a 4 instead of x squared. So when I do, anytime that you have a binomial that you have an x to the 4th, you can still do the difference of two squares, because the square root of x to the 4th will be x squared. But this is going to give you a hint that you might have to go a little further. So the square root of 16 is 4. Whoops. The square root of x to the 4th is x squared. Let me rewrite that. So the square root of 16 is 4. The square root of x to the 4th is x squared. The square root of 89 is 9. So I'm going to have one with the minus and one with the plus. Now, notice that this first binomial, I can do the difference of two squares. Again, I can take the square root of 4, I can take the square root of x squared, and I can take the square root of 9. And there's a minus, so I can say the square root of 4 is 2, the square root of x squared is x, the square root of 9 is 3, one with the minus, and one with the plus. 2x plus 3. Now, the part that I'm hiding underneath my pencil, the reason why I can't go any further with this one is because it has that plus sign. So just like your GCF, it has to come down into your answer, but it cannot be simplified. So I simplified this one further by doing the difference of two squares one more time, but this polynomial had to go straight into my answer just like my GCF did, and that step above it, it just came down into my answer while I did the difference of two squares with the other polynomial. So this one I was able to factor further, but this one just came down to your answer. This is your whole answer in factored form. Okay, now we're going to pick up with your next section on the next video, but if you have any questions about difference of two squares, let me know.